Hello and welcome to my tutorial. I'd like to talk about one-way ANOVA with a Likert scale data. So if you've collected your data for the dependent variable using a Likert scale, so this video will guide you and support you in analyzing your data correctly. So I have this topic here, which is the effect of different teaching methods on student engagement and performance. Now in this study, I have the following dependent variables, that is student engagement and performance, to evaluate the effectiveness of three different teaching methods, that is the traditional, the interactive, and online pairs. Okay, so in this SPSS, I have already coded my data set for the independent variable here. In this case, is the teaching method. So you can see that I've got 1 to 30 as group 1, then group 2 from 31 to 60, and then the last group, which is group 3, from 61 to 90. So let me take you back to my PowerPoint. So you can see that in the learning task, what I will simply do is I will have to recruit students, 30 students each for the three different groups. And you can see the group 1, just like I've explained in the SPSS right now. And then so that will give me a total number of 90 respondents. That's how I got this 90. And here you can see that I've got my performance variable measured in a Likert scale questionnaire. So you can see this is item statement number 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then you can see that here I've got engagement measured with 10 item statements, and so you can see how people responded to that. Okay, then for the teaching methods here, you can see it was also coded. You can see the traditional, the online, and the interactive approach. Okay, so this analysis will lead me to posing the following null hypothesis: there is no significant difference in student performance among the three teaching methods, that is the traditional, interactive, and online self-paced. And then the second one, because I have two dependent variables, remember, student performance and student engagement. So I now pose the second null hypothesis. And of course, you know that the alternate hypothesis or the alternative hypothesis will be that there is a significant difference. Okay? Now, let me take you to the analysis procedures that we have to follow to run the analysis. So the first check we need to make is to check the normality assumption. Here our focus is on the Shapiro-Wilk test. Okay, so if this test is statistically significant, then data distribution is not normal. All right, so here what we want to find out is to be sure that our data are normally distributed. Normally, in most one-way ANOVA analysis, people usually use test scores, okay, to achieve continuous variables. In other words, you need things like test score or height, weight that are already continuous. Okay, so we need to turn these into continuous variable to now have a variable called performance, student performance. So to do that, I'm going to click transform, and then I'll click compute variable. So here I'm going to write performance, okay, because that's the variable I want to now have. So I will go to statistical, and in this case, remember that you can use any of these any of these. The most used ones are the mean and the sum. So in this analysis, I'm going to use the sum. So I'm going to sum the item statements. So to do that, so I'm going to have performance item statement number 1, and then I'll press comma 2, comma statement number 3, comma item statement number 4, comma item statement number 5, comma 6, comma, and then 7 and 8. I'll click OK to create that particular variable called performance. Then the next one is engagement. So the same thing here, I'm going to click engagement, and then I'll use comma 2, comma 3, comma 4, 5, 6, 7, 8, 9, and 10. That's it. So you can see the variable performance is already here. So I will click OK, and then I will take you to my SPSS, so you can see that it has created the sum of the whole items for engagement has been created, the same thing as performance. Okay, so you can see them here. So if I had used the mean approach, I will also get a similar result. So the next thing I will have to do is I will have to check the normality test. So to do that, I'll go to Analyze, Descriptive, Explore. So you can see my data here. Then I will select the 2 dependent variables, and then I'll go to, so I will select this, the histogram and normality plot, and click OK to see the results. So this is the results. So you can see that in this analysis, the result of the Shapiro-Wilk test are not statistically significant. Even the Kolmogorov-Smirnov sig values are also not statistically significant, so indicating that the data are considered to be normally distributed. And another thing that you also want to look at is potential outliers. So you can see that here, for example, we do not have any evidence of outlier for performance, and same thing here for engagement. In the rectangular shaped figure, we also do not have any evidence, any sign of outliers. Supposing we do have, we will likely notice them here or here, but in this case we do not appear to have any outliers. So having confirmed that our data are normally distributed, the next thing we need to do is to check the homogeneity of variance assumption to know whether we will be violating the assumption or not as we run the one-way ANOVA test. So we go to one-way ANOVA, and how do you go to one-way ANOVA? You can click on Analyze, Compare Means, One-Way ANOVA. Okay, so here the 2 dependent variables, I'll put them here, and then remember my group, I will insert them into the factor box. Okay, then I would like to check the homogeneity of variance test. So this test is like the Levene's test. Okay, so in this case our interest is to be sure that the p-value for the homogeneity test is not statistically significant. So if the p-values are statistically significant, it means that we are violating the assumption and we will have to stop the analysis. Okay, and then choose any other non-parametric test. So at this point, we will perform the one-way ANOVA test, okay? So this is the first dependent variable here, which is performance, and then you can see that based on the mean, it's not statistically significant, based on median, and even based on median, and with adjusted degree of freedom, we did not violate that because it's still above 0.05 significant level, okay? And then also, let us look at the ANOVA test. So in this case, you can see that we did not find any evidence of a significant difference in the performance among the group, but we can see that there's evidence of changes in the mean of the group in terms of engagement. Okay, now here, since there is no statistically significant difference here because we do not find any evidence, we will not subject the performance to post-hoc test. So the next thing we need to do is to now report these results for performance, and then go further to test the Tukey test. Okay, one of the things that informed this study is that there's a recent study published in 2022 that talks about misuse of analysis of variance in African biomedical journals, a call for more vigilance. This is an interesting paper, and it assessed 126 articles and then found overwhelming results about the misuse of the test. And one of the things that this study talked about is that researchers do not probe their results. So in this case, what does that mean? If the results of the one-way ANOVA is statistically significant, in most cases people just end their results like this. They will simply report this only. This is not correct. So if you find a statistically significant result, you need to probe this result. So in order to do that, you have to perform a post-hoc analysis. So if the one-way ANOVA indicates a significant difference among groups, conduct post-hoc tests. Example, the Tukey's HSD, to identify which specific pairs of groups differ significantly among the group. Okay, so, and in this case, it's also known as the analysis of fact. And then if the result of the analysis of the ANOVA indicate that the F statistics and the associated p-value are not statistically significant, it means that there is no sufficient evidence to suggest that the different teaching methods have a significant effect on either student performance or engagement. So in this case, you can see that we do not have sufficient evidence. All right, so what we need to do now is to conduct the post hoc test and then removing the performance variable. So I will remove the performance variable and then run a post hoc test. Here I will select Tukey, okay, and then click OK. So in this case, we have the comparison here. So you can still see the homogeneity test here. They are all not statistically significant, so showing that we are still not violating the assumption of the homogeneity of variances. And then you can see the ANOVA, the F statistics here is also high, 18.455, and is statistically significant. So we can copy this and paste here. Here, and then the comparison test to now do an extensive interpretation of the results. So I have pasted the results here, and I've interpreted the results, so you can actually pause the video at each point to read through the results. So let me start with the homogeneity test. Like I explained before now, so you can see this is the table for homogeneity test for engagement. And so the original interpretation is that the homogeneity test was conducted to assess equality of variances across the 3 teaching groups, and the test was not statistically significant, indicating that the assumptions of homogeneity of variances was met. Therefore, the result of the one-way ANOVA for student performance and engagement are valid and can be interpreted with confidence. So this is the reason for conducting the homogeneity test. And so that leads to the F statistics. So you can see how I also reported the F statistics for both dependent variables. So the F statistic for performance was not statistically significant, indicating that there is no sufficient evidence to suggest that the different teaching methods have a significant effect on student performance. So you can see how I reported this, and that is here you can see that's performance. You can see the F statistics. This is the F test result, and this is the sig value, the significant value, 0.18. So you can see that here, 0.18. You need to also report this. And then the F statistics for engagement was statistically significant, so indicating that we have evidence that there's an effect on students' engagement. So you can see this is the F result test, and is statistically significant, just like we demonstrated in the result that we've got. So the next part is, having found a statistically significant result here, so we now have to undertake the toolkit test for multiple comparison. So this is specifically for engagement. Remember, this is specifically for engagement because it is only the engagement that is statistically significant. So there's no need to conduct the toolkit test for performance because it is not statistically significant. So you can see the results here, and from here you can see that the comparison under the traditional method, you can see comparing traditional to online is not statistically significant, but when comparing traditional and the interactive teaching method is statistically significant but less. So look at how I interpreted that. You can also pause to read that. Okay, the result of the toolkit test, that is the post-hoc test, showed a non-statistically significant mean difference when comparing engagement in the traditional and online self-paced teaching method, that is this, but also showed a negatively significant mean difference between the traditional and the interactive approach. Okay, so that is this result, and so you can see that result here, that is this. And then the online approach, also the results showed no statistically significant mean difference when comparing engagement in the online self-paced and traditional method. Okay, that is this, but showed a negatively significant mean difference between the traditional and the interactive approach. So you can also pause the video, and also, so that is this point. And then lastly, the comparison between the interactive, traditional, and online. So you can see, lastly, the results showed a positively significant mean difference when comparing the interactive and traditional methods. Okay, that is this, and then that is 9.46 and is statistically significant, and the interactive and online, that is this. So you can also pause the video to take a look at that. That is this particular point. So the overall comparison here is that engagement was significantly lower in the traditional method compared to both the interactive, that is this, and online test, that is this. However, engagement was significantly higher in the interactive method compared to both the traditional and online paste. So you can see the result here. So this is exactly how you can run this type of analysis, comparing three different groups to see how the results will look like. I hope you learned something new today, and if you have time, please, you can take your time to download this paper. The good thing is that it is open access, so you can download it and take your time to read through, so you'll be able to avoid the misuse of one-way ANOVA. Okay, thank you so much for watching. If you find this video interesting, please like the video and share, and then subscribe to my channel so that when next time I do a new video, you'll be able to get a notification. That is, if you turn the notification bell on, you'll be able to get a notification when next I post a new video. Thank you so much for watching.